Hey everyone, John with the GSSI training team here to demonstrate the user interface of the SIR 4000. So I have my SIR 4000 on at the home screen here. As we can see along the bottom, I have a 350HS digital antenna attached to the SIR 4000. So using the wheel or the arrow keys to navigate around the interface here, we can see that we're currently in digital 3D mode. I'm going to click the wheel and rotate it to select digital 2D instead. Digital 2D and digital 3D are the options that you're going to have available to you if you have a digital antenna attached. If you have an analog antenna, you're going to have a different set of options. Digital 2D is the equivalent of expert mode when you have an analog antenna attached. So I'm going to demonstrate digital 2D here. Last used settings and new project would take us into a project, but first let's take a look at the physical buttons along the bottom of the SIR 4000. These have some settings that we can play with. The far left button lets me change the language. The next one lets me change the units between metric and English. The next one is not going to be used here. Most of our antennas in, I think, at least the last decade get auto-detected by the SIR 4000. They have what we call smart chip in them so that whatever control unit you have can detect what antenna is talking to it. If you had an older antenna, a much older antenna, you might need to select it manually here. We can set up our GPS from the main screen, but I usually prefer to do that from inside a project. Theme lets us change the color scheme of our device. And then in settings, we can adjust the date time settings, or we can click into firmware here to update the firmware of our SIR 4000 if we need to do that. I'm going to quit back to the main screen. Last used settings would take us into the last project that this SIR 4000 was used for. If we were returning to the same field site as yesterday, we could use last used settings, be back in the same project using the exact same settings. We're going to go to new project here, and that's going to open up this dialog box that lets us name our project. We can go to each letter or number and change it. We can add letters, remove letters. Just to demonstrate how this works, I'm going to change the number 1 to the number 9 here. You could change every letter here, add letters, remove letters, name it whatever you want. I'm going to hit apply, and now you can see we're in project 9, about to collect file 1 based on what's on top of the screen there. This screen is the setup screen. The antenna is currently collecting data, but the SIR 4000 is not recording that data. This is just a preview that demonstrates for you that the antenna is working, the antenna is talking to the SIR 4000, and it lets you preview any settings that you change during this setup process. It's not in data collection mode right now. That's a common mistake to make at this point. We're not collecting or saving any data. I'm going to first go through the 4 menus here and show you the settings that we can play with, and then I will go into data collection mode. So let's start at the top. The radar menu holds all the collection settings that you might want to change. I'll just go through all the settings in here one by one. The first one is collect mode. That's going to be either distance, time, or point mode. We're typically going to be working in distance mode in the modern times. Distance mode means that you have a survey wheel attached, and that survey wheel is going to tell the system how often it needs to take a measurement. Time mode is for when you don't have a survey wheel, either because you just don't own one or because you're in an environment where you can't use one, like a bathymetry survey across a lake or something like that. In time mode, the antenna just constantly collects data and sends it to the SIR 4000. I'm going to keep this on distance mode. Scans per second is really a setting for when you're in time mode, but it does affect a few things on the back end of the device. I'd keep this between about 100 and 130. I usually just keep it at 100 scans per second. Samples per scan sets how many samples we take of each individual measurement. Unless you're collecting more than maybe 20 feet deep, you can leave this at 512 samples per scan. If your time windows are getting into the hundreds of nanoseconds, if you're looking tens of feet deep, you might want to kick this up to 1024 samples per scan. But for most utility locating jobs, 512 is perfectly fine. And if you go up to 1024, it's going to double the size of all of your files. So I'm going to keep this at 512. Scans per foot is an important metric. That's how many scans we're going to take every time that the wheel determines we've moved a foot. So if it's set to 12 here, then every time we go 1 inch, the system is going to take a measurement. I typically set it to 18 or 24 for utility locating. 18 would be a scan every 3/4 of an inch. That's going to be enough to resolve pipes pretty clearly. And as you increase that scans per foot, it's going to slow down the rate that you can push the cart. So I don't like to set it too high. Feet per mark is just going to drop a line in your data every time you go that distance. That's not really necessary with modern surveys, so I'm going to set this to none. We could set the dielectric here, or we could set it once we've got a pipe in our data to calibrate over. We already have a video on using hyperbola matching on the SUR 4000 to calibrate your dielectric, so refer to that if you want to learn how to set your dielectric properly. You can also select from some preset dielectric values here under soil type. The depth range is an important thing to set correctly. You don't want to set it too shallow and miss things that you could have seen deeper down. And you don't want to set it too deep and compress all of your data into a small portion of the top of the screen, even though you can't actually see as deep as you're looking. What I usually like to do is set it quite deep, take a measurement, and then see, okay, how deep am I actually seeing at this site? And I'll set my depth range a little bit beyond that. So I might start out by scanning at 15 feet deep, even though I don't expect to see any utilities there. I don't even expect to see 15 feet through the soil, but I'll collect a measurement and then maybe I'll see, okay, I'm seeing 9 feet down at this site. So I'll then go back and set my depth range to something like 10 feet. If you have a line track device for listening for live power signals or specific frequencies, you can turn that on and off here. And I'll exit out either by going to exit and clicking the wheel, hitting the carriage return button, or hitting the back button right above the start button and below the D-pad. Now let's go down to the process menu. The first thing here is the gain mode. So you can either have the device do an auto gain or a manual gain. I typically let it do an auto gain. It does a pretty good job of that. But if I'm going to do an auto gain, I want to go to Edit Gain Curve and add points until it's at the maximum number of points, which is 8 gain points. And then I'll hit Save and Quit here in the bottom right. You can then have the system rethink the gain curve, either by switching it to manual and back to auto, or hitting the Enit button here, the leftmost physical button. When I hit that, it's going to reinitialize the antenna, and it will set the gain curve properly for whatever material you're sitting on. So if, for example, you set this up on pavement, but you're going to be scanning on grass, before you scan, get onto the grass and hit this Enit button, and the system will give you a gain curve that will work for that material. You could also set it to manual and then edit the gain curve manually, selecting whatever point you wanted and increasing or decreasing the gain at that point. I'll switch this back to manual for now. The other two options here are stacking or background removal. Stacking will do a moving average of your scans. It can remove the influence of high frequency noise that's appearing as static at the bottom of your data set. Background removal will remove horizontal noise bands from your data, but it will also remove any other horizontal features in your data, so be very careful with this. With background removal, a smaller number is a more aggressive filter. You can see if I set this to 2, it's going to remove everything in my preview there, because when we're just sitting in place, it's all horizontal lines. If I were actually going to be doing this in the field, I'd want to set this to maybe something like 1,000, collect some data and see how it looked, and then adjust it from there. But if I'm not using background removal, or if I don't know whether I should be, or when I'm finished up with the device, I'm always going to set this back to 0 so that it's not on by accident on a future survey, because again, it can remove real data from your data set. Signal floor, if we toggle that on, it will put a green line in your data where the system judges that you're not seeing any deeper. We're not going to see that in the preview here, but I usually leave this off. Backing out of process, we can go down to output. You can select the data path, which will let you navigate to a different project. You can change your vertical scale from depth to time or height. I'm going to typically be working with depth though. That's how we're usually thinking about our GPR data. You can change the units. So since we're in English, the options are inches, feet, or yards. If you're in metric, you're going to have centimeters or meters. There might be millimeters. I'm not 100% sure about that. And horizontal units, same thing, except now we've got miles, because while you're not going to look miles deep, you might walk a few miles horizontally. The scale color does what it says, switches you basically from light mode to dark mode. There are a couple different color options as well. Show O-scope determines whether you're going to see the A scan in your data or not. If I turn this off, we're not going to see the O-scope, which is this white box here that contains the individual measurement that was most recently collected or that our cursor is at. I usually leave that on. You can get some detailed information about your data by looking at the A scan or the individual measurements, but you can also turn it off here if you want some more screen space to dedicate to the B scan or radargram. Show hyperbola, we're going to leave that off. That's used to do hyperbola matching and calibrate your dielectric. Again, check out our other video on using the hyperbola matching function on the SIR 4000 to calibrate dielectrics. Color map switches the color scale that you're using to colorize your data set. 11 is the default, but your mileage may vary. You can peek at the other color scales here and see what works for you on any given project. And then color stretch and slide just lets you modify where the breakpoints are on that color map that you've selected. The last menu here is System. So if we click in there, there's a few hardware settings, brightness. If you can afford to turn the brightness down, that's the thing that uses the most battery, but if you're working outside, you're probably going to want that at 100%. Volume, sometimes the SIR 4000 beeps for a variety of reasons. This will affect the volume of that. If autosave is on, then whenever you stop a line, it will automatically save it, and it'll go to the next line number. If autosave is off, every time you stop a line, it will ask whether or not you want to save it. Save setup and recall setup are part of the system that stores settings here. So if we go into recall setup, there will be a few options here. 350 HS 3-wheel cart, 4-wheel large, 4-wheel small, and 620 SW. These are the different cart configurations for the 350 HS antenna that I currently have attached. If I didn't really know what I wanted my settings to be, I could use one of these options to just get some basic default settings that will work for the 350 HS antenna. I currently have it set up in a 3-wheel cart, so I would select 350 HS 3W cart if I were going to do this. I'm not going to select a default setup though, since I've already set up my settings the way I want them to be. However, if we go back into the system menu here, you can also save a setup. So if the settings that I've set here I'm going to use on multiple projects, I could save this setup by going into Save Setup and either selecting one of the pre-named setups here or hitting New Setup and giving a custom name to this setup. Then, whenever I went into Recall Setup in the future, that setup would be there. I've already done this before with the SIR 4000, so you can see I have setup 01 in my recall setup options. That's a custom setup I made for working around our headquarters here in Nashua, New Hampshire. Now we're going to take a look at the last two options in the system menu here. After recall setup, we have this calibrate SW option. That's where you can calibrate your survey wheel's distance encoder, and it's going to walk you through the process here. Again, I don't have a lot of space indoors, so I can't do this myself, but we're always going to use quadrature for our survey wheel mode, and then we're going to follow the 1, 2, 3 step process there on screen. Number 1, select a calibration distance. You don't need to use a very long distance. The encoder is very precise. 10 feet's more than enough. Then you'll line your cart up at the start of that 10-foot mark, tap the start button, push the cart to the end of the 10-foot line, hit the stop button, and then hit apply. It's not going to let me do that here because I didn't push the cart, so I don't have a calibration value here, but it's a pretty simple process. Last is GPS config. This is where you would set up your GPS and begin data streaming. The setup of your GPS antenna is going to depend on whether you have a digital antenna or an analog antenna. It's going to depend on the GPS receiver that you use. So the baud rate might be different. The requirements for the output from the GPS receiver might be different depending on the brand of receiver you have. Take a look at the manual to make sure you're setting up your GPS right. But with your GPS connected to the SIR 4000, you'll turn this GPS state to on, set the correct baud rate, whatever that might be for your system, and tap the start button to begin the GPS stream. We're not going to get anything here because I don't have a GPS, but the GPS is now enabled, and we would have lat-long values streaming and tied to our GPR data if we actually had a functioning GPS. And then there are just a few more things along the bottom, but these are mostly going to come into play when we're collecting. So now if I want to actually start collecting and saving data, I'm going to hit the start button. And now we're in collect mode. If I push the system forward, we'll start collecting some data. And if I back up, the cursor will back up within the data. I'm indoors here, so I can't collect a large amount of data to demonstrate this, but we're in collect mode. If I press stop now, it's going to, if I hold stop rather, it's going to take me back to the setup screen. And you can see that the next line it's going to collect is 002. So let me just explain the start and stop buttons here because they can be a little confusing. If you hold the stop button, it's going to take you up one menu level. So if I held stop now, it would take me back to the main screen. I don't want to do that. If I want to go into collect mode, I tap the start button, just a quick press of it. And now I'm back in collect mode. Let me collect some dummy data here. Now again, if I wanted to go back to the setup screen, I could hold down the stop button. If I just want to stop data collection for this line but stay in collect mode, I can tap the stop button. The green light on the SIR 4000 will turn off, indicating that we're no longer collecting data. And now if I want to start a new line, I can tap the start button and it will open a new line, now file number 3. The other way you can get to a new line is just by holding the start button. Now we're collecting line 4. There are a few options along the bottom. Let me collect a little more dummy data here. And then we'll just look at what these options are. It's not gonna, all of these options aren't necessarily going to work since I don't have real data with point reflections or individual targets in it, but I can demonstrate what these buttons do. Focus mode is basically it's going to do a migration to your data. What that does is it gets rid of the tails of hyperbolas, so it'll just turn them into bright dots at the peak of where that hyperbola is. It's not too common to do that in real time with your data. Next, this gain option is display gain. So if I select that, I can turn up or down the gain on the line that I'm currently collecting. This change to the gain does not get saved to your data. It's just a display gain. It just affects what you're looking at on screen in real time. Zoom here will stretch or squish your data. H cursor, you can toggle from off to move to raise or lower this horizontal cursor here. And then turn it back off. And then you can change the dielectric. But again, refer to our video on using hyperbola matching to do that properly. And in the output menu, we have a few options. Most of these you probably won't be editing while you're collecting. You can change the dielectric. You can Hilbert transform your data. This show hyperbola option is what we would use to do hyperbola matching. You can change your color map while you're collecting if you want to, and also stretch or slide that color map to change how it works. Now I'm going to hold stop to go back to the setup screen, hold stop one more time to go back to the main screen, and I'll take a look at playback mode here. Playback mode takes me into the file structure and shows me all the files in the project I'm currently working in. So you can see we're in project 009 here, and you can see the 4 lines I've collected. I can select any of these by clicking the wheel to select them. And this is one place where the wheel and the return key in the directional pad work differently. The return key here is actually going to play these files. And now if I hit start, it's showing me line 001, that very first line that I collected with that little sliver of dummy data. So you can review lines like that in playback mode. I'm going to back out to the main menu again and go back into playback here. You can also transfer your files. So along the bottom, you see these 2 grayed out options, copy to USB and move to USB. If I plugged a USB drive into the top of the SIR 4000, those options would become available. And I could then hit copy to USB to move these 4 files onto a USB drive for transfer to a PC. Make sure that you never use the move to USB command. The move to USB command gets the files off of the SIR 4000. It deletes them from the SIR 4000 and transfers them onto the USB drive. But if anything goes wrong with the file transfer, those files will be gone. So if the USB drive doesn't have enough space for the files, if the SIR 4000 runs out of battery in the middle of the transfer, if the USB drive is damaged and not working properly for any reason, if you try to use the move to USB files, the files will be gone if they don't properly transfer to the USB stick. So always use the copy to USB option in my opinion. You can also delete files here. There's nothing really important in this data set, so I'll delete all 4 of these files. And that's pretty much everything on the SIR 4000 user interface. Feel free to ask any questions in the comments or reach out to training@geophysical.com and reach out to sales@geophysical.com for a quote.